Hey guys, I'm Pat Kelly. Okay, in this problem, they ask us to evaluate this integral. That's what's given to you. And they also give you this path that I've already drawn out, but they mention the coordinates of the points that you travel from and to. So I've got this path going on over and up, and I'm kind of pausing and going slowly here because I'm hoping this kicks in your head and you're thinking, usually we have to rewrite that type of path as some kind of parametric representation. And if you're thinking that way, you're right. So that's the way I'd like to begin, is by parametrizing this path. And I'll even try to keep it color-coded if you want, is this bottom path I'll call C sub 1. I'll try to do that work in blue. And this side path here is C sub 2. I'll try to do that in green if I can, all right? Okay, but to start, let's actually try to write our R vector as a function of time. And to parameterize this, I'm thinking of that first path. My x-coordinate needs to go from 0 to 3. I think it's going to be easiest if I just make that t times the I vector. And my y-coordinate stays at 0, so there's a 0. If you want to write it, it'd be 0 times the j vector. Okay? And then my restricted domain on that would be, if you noticed even my x-coordinate of being t, I needed x to go from 0 to 3. What I was thinking in my head is that I would let t go from 0 to 3. Okay? And that's helpful for me because then down in my second branch, when I go to do that second leg of the trip, I'm going to start at 3. I'm trying to make sure I have enough space for this. Should be good there. And you've done enough of these. If you know your t can really be almost anything, it's going to make sense for me to just make it a 6, though, to keep those increments the same. All right, so now in order to get this second leg of the journey, my x-coordinate stays at 3. So I think I like 3i. I got to think about my y-coordinate here. Needs to start at 0 and then go up to 3. So t minus 3 is j. I always like to check that. If I put in a 3 here, 3 minus 3 is 0. It's good to start from my y-coordinate. Plug in the 6. 6 minus 3 is 3, which is good for my y-coordinate. I think I'm good. This would be my piecewise function for r. Now let's get to our work over here. And I think I had promised you some color coding. Let me do my work for C1 in blue. And what I want to do, really to lay it out, make sure I get all the pieces of the puzzle for what they're asking me for, is I want to state explicitly what's my x of t for this branch C sub 1. And that's actually just your t right there. And I'll even state my y of t, which I know was 0 right here. And one of the reasons I want to state those so explicitly is because I want to see what x prime is, just differentiate. That just equals 1 here, y prime of t equals 0 here. And the reason why that's significant is because your derivative here then of x, think of this as dx over dt, because we're differentiating with respect to t. And then we're going to throw our dt on the other side, kind of cross-multiply type of idea. And the reason why I like that then is because that's going to give me a substitution for dx. Where I see dx for this branch, I can replace it with dt. This one's actually even easier. Your dy, again, think dy over dt, but when you multiply the dt over the other side, there's a 0. That's why that's easier. You get 0, okay? All right, now let's get into this integral. And so the integral here will equal, and I don't have limits of integration specified when we have this generic C, your path, but our limits of integration in terms of t, we know, they're going to be here. So I'm going to go from 0 to 3. And now I'm looking to plug in some specifics here. 2x, and x is staring at you right there. One of the reasons I wanted to have it ready for me. So that's going to be 2t minus y, but my y is 0. That's being multiplied by dx, but my dx is dt. And so I'd be done with that part of it. There is another part of it, plus all of this, but dy is 0. So for us, for this path, that dy is 0, so that whole second part blanks out to 0. So this is ready to go. That's good. So 2t, that's just a t squared. We're evaluating it from 0 to 3. No need for a calculator on that one. I just get 9. Okay. Might use a calculator for this next one, so if you want to have yours ready. My second path, I used green, I guess, but c sub 2. I'm going to go through all the same work. Let's lay out our x and our y. X of t equals 3. Y of t equals that t minus 3. I like those staring at me so I can get my derivatives pretty easily. Derivative of 3 is very easy. That's a 0. Y prime t is just going to equal a 1. That's pretty friendly as well. I now know that dx equals 0 and dy equals dt, which allows me then to go back up to this integral, and let's substitute. I come down here if there's going to be enough room. Integral. This time my limits of integration are 3 to 6. Should make sense, I hope. 3 to 6. This time my first term inside there is going to be the one that blanks out. This is convenient. It's very fortunate for us, but the dx goes here to 0, so that's gone. I just need to worry about this second part. So my x is 3, and then there was a plus sign. I'm looking here. And then 3 times whatever y is, so 3 times, and I'm grabbing my y from right there, t minus 3. And that's actually all here together with a dt. Sorry, I should even explain that. dy became dt for us, right? Okay, so now this integral is all in terms of t. It's ready to go, I think. So let's see if I can go over with this one. I'm going to do a little bit of combining as I go, because I see there's going to be some like terms with the constants. But the 3t, if I anti-differentiate, I'm looking at 3 halves t squared, all right? And the 3, be careful, 3 times the minus 3 is minus 9, and I'm combining that with the 3. So it looks like a minus 6t when you anti-differentiate. And we still have our limits of integration going from 3 to 6. Let me slip down a line and put in some numbers. But here's where I'm feeling like I might head to my calculator. So putting in the 6, we get 6 squared. So 3 halves times 36. Minus 6 times 6, that's another 36. Subtracting what happens when you plug in the 3, so I'm putting in a 3 here, 3 squared, actually 27 halves. Subtract, be careful, so that's going to be a plus 18. I warned you I was going to be lazy there, so I'm going to grab a calculator for that one. But I'm putting in 3 times 36 over 2 minus 36 minus 27 over 2 plus 18, and I'm getting 22.5. I think a decimal's okay, or as a fraction, I guess, as well, 45 halves if you want. Either way, we're almost done, not quite done. I just need to put them together. Our final answer here, this overall integral, is going to be the sum of the two integrals. Okay, so I'll stick in green, I guess, but this integral equals, and all you're doing is adding 9 plus 22.5, or the fraction equivalent if you want, but I guess we're looking at a 31.5 as a final answer. There. Okay, hope that helped. Try some more on your own. I know you'll do well.